Hello. In this video, we will cover section 9.4, which is on hypothesis testing for means. In chapter 8, we use the central limit theorem for proportions to test a hypothesis about the population proportion. This involved a four-step process that was called the hypothesis test for proportions. We can use a very similar process with only minor modifications to test a hypothesis about a mean. All right, let's go through the four steps as review. So the four-step process for performing a hypothesis test is below. The steps do not change when testing a mean instead of a proportion. So first we hypothesize, we turn the statistical statement that's given in the problem into a pair of hypotheses about the population parameter. We then go through and collect or examine data that we're given, and we check that that data meets the central limit theorem. We then analyze the data by stating a significance level and calculating the test statistic, and then finding the p-value using the test statistic. And then we go through and we compare the p-value and the significance level to determine whether to reject or not reject the null hypothesis. All right, so we're going to now dig into the specific steps to discuss the changes, by using a mean instead of a proportion. So the first step does not change really at all, except you're going to use a mean instead of a proportion. So if you go back to the video where we covered hypothesis, where we first introduced hypothesis test, it had a table that looked very similar to this. The only difference is that in place of these mu's, which stand for means, we had p's, which stand for proportions. Everything else exactly the same. When it comes to collecting or examining our data and checking the central limit theorem conditions, we use the central limit theorem conditions for means instead of the central limit theorem for proportions. So hopefully that makes sense. And the central limit theorem for means are what's displayed here. We then go through and do the computational part of the hypothesis test. So this does involve some significant changes. So we're going to go through and use the t statistic formula. So that's written here. And of course, we use the standard error formula for, for means as well. So we're going to go through and use means formulas instead of proportions formulas. So hopefully that makes sense. And then since we're using t statistics, so those go along with a t distribution. So because of that, we want to use the t distribution when calculating the p-value instead of the normal distribution. So normally when you go through and do this with a proportion, you open up the normal calculator in StatCrunch when you're going through and calculating the p-value. Here, instead, you're going to open up the t distribution calculator, and you're going to do everything else the same. So everything that you did with the normal distribution calculator, the way that you entered all the information in there, you're going to do the exact same thing with the t distribution calculator instead. So those are the only differences. You use the t statistic instead of a z statistic, and then you use a t distribution instead of a normal distribution. And then finally, when it comes to interpreting the results, we don't change anything. So you just compare the p-value and the significance level. If the p-value is less, we reject the null hypothesis. If the p-value is greater, then we fail to reject. All right, so let's just look at some quick examples here. So McDonald's advertises its ice cream cones have a mean weight of 3.2 ounces. A human server starts and stops the machine. So we expect some variation. Some cones are going to weigh slightly more. Some cones are going to weigh slightly less. If we weighed all the McDonald's cones at a particular store, would the mean be 3.2 ounces? So we've got a sample of 5 ice cream cones is collected, and their weights are listed there. We're told the data is summarized as the mean of this sample is 3.68, and the standard deviation of this sample is 0.3701. We're told to go through and perform a hypothesis test to test whether the mean weight is 3.2 ounces using a 0.05 significance level. All right, so we go through and we create the rival hypotheses. So the rival hypotheses, if the null hypothesis is equal, alternative hypothesis not equal. So we've got the central limit theorem conditions. So the sample was collected randomly. So you can see it does say somewhere, I think in here, yeah, collected randomly. So that meets that condition. And then this one is a little hairy in this particular case. So we're told that some cones weigh slightly less and some cones weigh slightly more than 3.2 ounces. So we're told the distribution is symmetric. And then if you just think about it, it's reasonable to assume if somebody's going through and they're activating an ice cream cone machine and they're trying to get 3.2 ounces, that they're going to be more likely to be close to 3.2 than far from it. And so the distribution is going to be normal shaped, right? So it might not be perfectly normal, but it's going to be normal shaped. And then finally, the large population, there's going to be more than 50 ice cream cones. All right, so the next part, which is the part that you may be most interested in, since that's the part that's the most different, we go through and we calculate the test statistic. So to do that, you first need to calculate the standard error estimate formula. So we put in the standard deviation for the sample and then the sample size, right? So what was the standard deviation for the sample? You got to go back a couple. Standard deviation for the sample, it's written right here, 0.3701, and the sample size is 1, 2, 3, 4, 5. All right, so we put 0.37015 and 5 in, calculate that, and you get this number. Then to go through and do the test statistic, you use this formula, plug everything in. All right, so the mean for the sample, so that was also a couple pages back, 3.68, they gave it to us. Okay, and then we're comparing that with, this is going to be the mean value for the null hypothesis, and that is 3.2. All right, so that's, we get 3.68 minus 3.2, pop the standard error estimate in there, and we get about 2.9. So to go through and calculate the p-value, you're going to open the t-calculator in StatCrunch, select between for a two-tailed test, enter 4 degrees of freedom, right? 4 comes from the side, you take the sample size and subtract 1. You're going to take this t-value and you're going to put that in the left and the right inequality. That's what you do when you have a two-tailed test. You're going to have both tails, 2 sides, and then you're going to have and press compute. And when you do that, you're going to get this. All right, so let's just see that. All right, so first of all, where's the t calculator in StatCrunch? So here's the normal distribution. Where it is? There it is. Here's the normal distribution calculator. So we're just selecting this one instead. So when you're doing means, do this one. When you're doing proportions, you do this one, and when you're doing means, you do this one. All right, that opens up the calculator. You want to select between for a two-tailed test, right? So this is actually not the two-tail, this is the area between the two tails, but that's the only way that StatCrunch works, is you've got to select between, and then we're gonna end up subtracting from 1 to get the area that's in the tails. Okay, so you select between, that gets you this between setup, enter 4 degrees of freedom, put negative 2.9, that's our left side, put positive 2.9, that's our right, enter, hit compute, and then you get this. Okay, so what is that? That's the area that's between the two. That's not what we want, though. That's not what you're supposed to calculate when you're doing a two-tailed test. You're supposed to calculate the area that's in the tails. Well, the area that's in the tails is going to be the opposite of this. Okay, and so what we need to do is we need to take this and subtract it from 1. Okay, so let's go back here. So now you can read through all this again, and you can see that we did get this value. And then you can see I said this is the area between the tails, which is, repeating myself here. We want the area in the tails, so you need to subtract from 1. You do that, you get 0.044. So this is our p-value. Okay, so if you need to watch that again to kind of get all that information, but that's how you go through and do it. That should feel very familiar. It's basically the exact same thing you did with a normal distribution calculator. You're just doing it with the t-calculator instead. Okay, and then the final step is you compare the significance level with the p-value. If you go through and look at this p-value, 0.044 is less than 0.05, and so because of that, we reject the null hypothesis. And so we would say the mean dispensed ice cream is not 3.2 ounces, right? So the null hypothesis is that it was, so that means that we reject that, and so it's not. Okay, another example. So in 2011-2012, the mean cost of all two-year colleges was $3,831. A random sample of tuition prices at 35 two-year colleges is collected during that year. We're told that the mean of those 35 colleges is this. The standard deviation is this. Test the hypothesis that the mean tuition has increased since the 2011-2012 academic year. All right, so step 1, create the rival hypotheses. So we've got that the mean is not changed. It's still 3831 versus the alternative hypothesis, which is that it has increased. Check the central limit theorem conditions. The sample was collected randomly. If you go through and you look, it says somewhere in here that random sample. Large sample, the sample size is 30, which is 25 or larger, so that's good. And then we do have more than 300 two-year colleges. So the central limit theorem conditions are met. And then we want to go through and calculate the test statistic. To do that, you start off with the standard error estimate. There's the formula. We take the standard deviation that they gave us, right? It's right there, 2589.8137, okay, over the square root of the sample size, which is 35. Plug it all in, you get that number. Then to go through and find the t statistic, or t value, you plug all this stuff in. So you take the mean from the sample, so 4173. So that is given here. That's the mean of the sample. So take that, plug it in, minus the mean value for the null hypothesis. So that's 3831. Put that there, and then divide by the standard error estimate that we just got. And if you do all that, then you get the t value of 0.78203614. And then to go through and turn that into the p-value, open up the t calculator in StatCrunch, enter 34 degrees of freedom. So the degrees of freedom is the sample size minus 1. So put that in. Change the inequality to greater than. So you want the inequality to match with the alternative hypothesis. Enter the t statistic that we just calculated, and then press compute, and you should get this. And you can see this is what it should look like. So you got 34 greater than the 0.78, you get 0.2198. And then the final step is to compare the significance level with the p-value. P-value is this, significance level is that. The p-value is greater. If the p-value is greater, then you fail to reject, so there's not enough evidence to support the case that the prices have increased. All right, and now let's do a homework problem for the third example here. So we've got the weights of 4 randomly and independently selected bags of tomatoes labeled 5 pounds at 5.1, 5, 5.4, and 5. Assume normality of the distribution, and then test the hypothesis that the population mean is not 5 pounds using a 0.05 significance level. All right, first create the rival hypotheses. So we're testing the hypothesis that the bags of potatoes are not 5 pounds, so that's our alternative. And the opposite for that, our null hypothesis, is that it's equal. The central limit theorem conditions, the sample was collected randomly, so it does say that in here, random and independently selected bags. The distribution is assumed to be normal, so we don't need to check, so we don't need to have 25 or greater. Where does it say that? Oh, sorry. It says assume normality. That's what that piece means right there. So assume the distribution is normal. So that meets the large sample requirement, and then the large population, we're presuming that there's more than 40 bags. Calculate the test statistic. So if you're going to go through and do this, if they don't give you the mean and the standard deviation for the sample, then that means that you need to calculate it yourself. Okay, so that's an important thing that could trip you up when you're going through and you're doing problems on the homework, is you get there and you're like, what's the sample mean and standard deviation? Well, they expect that you can go through and that you can find those. Okay, so you can use StatCrunch to do it, or you can use some other statistical software, but you should get that the mean of the sample is 5.125 and the standard deviation of the sample is 0.189299694. All right, the standard error estimate, plug everything in. You got the standard deviation that's right there. You got the sample size, square root of 4. You should get that. And then t is equal to x. So anyway, there's the t statistic formula. Plug everything into that. The 5.125, that's x bar. The 5, that goes along with the null hypothesis value. And the standard error estimate is written right there. Just plug it in. Simplify all that, you get this. All right, so to go through and calculate the p-value, again, we're doing a not equal. So not equal goes along with a two-tailed test. So we need to go through and select between, then enter 3 degrees of freedom, right? So the degrees of freedom is the sample size minus 1. So sample size is 4, 4 minus 1 is 3. And then you take this value here and you put that in next to the 2 inequalities, and then you press compute. Okay, and you get this. So got between selected, 3 degrees of freedom, the negative value, the positive value, and this score. Now, what this is it's the area that's between these two. That's not what we want with a two-tailed test. We want to know the area that's in the tails. Okay, so what we need to do is we need to go through and convert this so that it's the area in the tails instead of the area that's in the middle. So to do that, you take this score here and you subtract it from 1, right? So the sum of all the area under the curve needs to be 1. If the area in the middle is 0.72, then you can subtract 0.72 from 1 to get to the rest of the area. If you do that, you get 0.27831241. Okay, so that is the area that's in the tails. All right, so finally we go through and we compare the significance level with the p-value. The p-value is 0.27. It's bigger than the significance level. So since it's bigger than the significance level, we fail to reject the null hypothesis, right? So there's not enough evidence to state that the weight is different from 5 pounds. Okay, and that's it. So that's 3 very quick examples, but hopefully this all seems very familiar because it's basically the exact same process as you did for finding hypothesis test for proportions, with just some little tweaks here and there, slightly different formulas, and a slightly different calculator that you use in StatCrunch. Okay, thank you for watching. I'll see you next time.